Hey everyone! We hear about climate change all the time, right? But today, we're going to look past the usual headlines. We're digging into some of the scientific details that make the climate story far more complex and, honestly, a lot more fascinating than you might think. All right, let's get into it. So, we all feel like we have a pretty good handle on the basics. But what if the story has a few more twists and turns? What if the relationship between cause and effect isn't just some straight line on a graph? Well, that's exactly the question we're going to tackle today. And look, this simple story is a really solid starting point. It's not wrong, human activity, CO2, a warming planet. That's all true. But you could think of this as just the opening chapter. The full story, it's got some puzzling history and a surprisingly tricky debate about which greenhouse gases we should be most worried about. And that first big complication in our story actually comes from looking back, way back, at the planet's own temperature record. It turns out global warming hasn't been this smooth, steady ride up. Yeah, take a look at this. It shows that the warming has really happened in fits and starts. See that first chunk of time? The early 20th century warming. The planet warmed up quite a bit back then, but then it kind of flatlined for a few decades before taking off again. This stop and start pattern is a huge clue that while CO2 is definitely the main character in this story, it is not the only actor on the stage. So what on earth was going on back then? Well, a whole lot of research shows it was kind of a mix of everything. Yes, greenhouse gases were already starting to have an effect, even then. But you also had fewer volcanic eruptions, which usually have a cooling effect. The sun got slightly more intense. And then there's the big one, natural climate rhythms. Things like long-term ocean cycles, which can shift weather patterns for decades at a time. All these factors basically ganged up to create that early warming period. It's a perfect illustration of just how many different knobs and dials are controlling our climate. Okay, so if the pattern of warming is complicated, what about the cause? Is it really all about CO2? Well, that brings us to another major character in our climate story, methane. You know, the best way to think about the difference between methane and CO2 is to picture them as two different kinds of athletes. Methane is the sprinter. It has this incredibly powerful, super fast impact on warming, but it burns out fast. It's gone from the atmosphere in about a decade. CO2, on the other hand, is the marathon runner. It's less potent at any given moment, but it just keeps going and going, sticking around for hundreds of years. This difference in their style is absolutely critical to understanding the whole debate. So, to compare these two very different athletes, scientists came up with a metric called global warming potential, or GWP. The idea is simple. How much warming does 1 ton of a gas cause compared to 1 ton of CO2? But, and this is a huge but, here's the catch. It all depends on the time period you choose to measure. And that choice isn't just a scientific one, it's a value judgment about what you care about more. Okay, let's see how this actually plays out. If you decide to look at a 20-year time frame, methane looks like an absolute supervillain. It's over 80 times more potent than CO2. This is our sprinter, right, at full speed. If you only look at this number, you'd probably think that cutting methane is the single most urgent thing we could possibly do to slow down warming right now. But what happens if we zoom out to a 100-year time frame? This is the metric people use most often. Well, the picture changes a lot. Methane's GWP drops all the way down to about 27. Why? Because over that century, most of that methane has already broken down and vanished, while that marathon runner CO2 is still just plugging away. So is methane 80 times worse or 27 times worse? The answer is kind of both. It just depends on the time frame you're focused on. And this scientific nuance, this isn't just some academic debate for scientists to argue about. It creates this massive, real-world dilemma for policymakers who have to figure out where to spend limited time, money, and political energy to fight climate change. And this naturally leads to two very different schools of thought. One camp says we have to prioritize methane. They point to that 20-year number and say we need to slam on the brakes now to slow down short-term warming and avoid hitting some catastrophic tipping point. But the other camp focuses on the 100-year view. They argue that because CO2 is the marathon runner, it's the only one that really matters for long-term temperature stabilization. To actually stop the planet from getting warmer, CO2 has to go to net zero. Methane, technically, doesn't. So we've got these competing scientific metrics. And just to make things even more interesting, economists weigh in with a totally different way of looking at it, the social cost. This tries to estimate the total economic damage, in dollars, that a ton of each gas will cause over its lifetime. And when you run those numbers, you get a ratio of about 21 to 1. So now, if you're a policymaker, what do? You've got people telling you the right number is 80, others saying it's 27, and another group saying it's 21. It is a genuinely complicated choice.
And what we're finding is, as our understanding of the climate problem gets more and more detailed, the debates over the solutions, well, they get even more complex and sometimes a lot more heated. Which brings us to the future of this whole debate. You start seeing headlines like this one, arguing over these huge, really controversial ideas, like geoengineering, which is basically deliberately intervening in the climate system. Now, that's a whole other can of worms, but it just goes to show you, as the stakes get higher, the choices we all face become even more profound.
So, no, the climate story is not simple. It's this complex dance between short-term sprinters like methane and long-term marathon runners like CO2. But acknowledging this complexity isn't an excuse to do nothing. If anything, it's a call for a much smarter strategy. It forces us to ask the really tough questions. Are we trying to win the sprint to avoid some immediate crisis, or are we pacing ourselves to win the marathon and secure a stable future? The truth is, the right path probably involves doing both. But knowing the difference between the two, well, that's where the real work begins.